Hey, it's me, Steve. It is May 17th, 2017. Time is 10:31. Temperature is 81 degrees Fahrenheit out. I am heading to deposit a check. My new washer and dryer came today, so I can finally do laundry since I bought the house like a month ago. But it's Geo-Rant time. And I'm just going to talk about this. This was kind of cool. There's a guy on YouTube. He's a physicist, I believe. Pretty sure he's a physicist. His name's Thunderfoot. He's a professor. Well, he likes to do these cool experiments. Like he did one recently where he took gold and put a diamond on it and hit it with different weighted hammers to see what would happen. Well, of course, when he hit it, he has a slow motion camera, so you can actually watch this like 10,000 frames a second. It's pretty cool. I'll put the link below. But when he hit the diamond, it flaked. It pieces broke off, and the underlying gold just bent and kind of turned. It was kind of cool. But this is why the diamond flaked. Okay. Now, diamonds are the hardest substance known to man, but because something's hard doesn't mean it's indestructible. Okay. Now, I'm going to talk about the metals first: gold, silver, platinum, copper, palladium. Everything in the right part of those transition metals on the periodic table, when they form crystals, they form what's called isometric or cubic crystals. Those are the simplest crystals. There's 6 crystal systems. Isometric's is simple. It's when you have 3 axes and they're all equal to each other. A is equal to B is equal to C. Now, that doesn't mean all isometric crystals look like cubes. You can... If you take a cube, as long as A is equal to B is equal to C, you have an isometric crystal. So if you take like 2 pyramids and stack them on each other, it's still isometric, like in an 8-sided die, role-playing die. Or if you take a cube and you shave the corners off, you still have an isometric crystal, okay? But metals, now, the reason why the diamond flaked and the metal bent had nothing to do with chemical composition or properties, although the chemical properties are what form the crystals. That's how we get minerals, okay? It had to do with the physical properties, okay? Now, like I said, the right of those, the precious metals, the right side of the transition metals on the periodic table tend to, their properties are almost exactly the same, other than color. And it's weird because they're all, in specific gravity, they're all essentially, their physical properties are the same. They're soft, they're malleable, they're ductile. Sorry, I'm on the highway and it's idiot hour. They want to bend. That's why they don't make rings out of pure gold. It's not to be cheap. It's because if you take pure gold and you were to set it on the edge of a table with a little bit hanging off, like if you could afford to, it'll start to bend because it wants to do that. It's soft. I believe most precious metals have a hardness of like 2.5 to 3. Where diamond's a 10. But so why did a diamond flake? Now, I said isometric crystals. Since isometric crystal system is the simplest, most things will form isometric crystals. Let's see, even more complex minerals, galena, salt. I had a bunch of them in my head and I just lost them all. Pyrite, and diamond. Okay, diamonds form isometric crystals, but why did the diamond break as opposed to just bend? Well, nothing to do with the chemical properties, had to do with the physical properties. Although diamond is extremely hard, diamonds have what's called cleavage, okay? That means it will cleave, like along a planar surface, it'll break off if hit hard enough or exposed to enough temperature or weathering or whatever. Eventually it's going to flake off. Enough pressure, and diamonds, although they are isometric, have 4 planes of perfect cleavage. Okay, so that's weak zones along the faces. So when you hit it with something heavy, apply a lot of force and pressure to it instantaneously, it's going to break. It's going to flick off. Okay, so that's why when he hit the, he had the diamond up here and the gold down here, he hit it with different weighted hammers. The diamond flecked off and the gold just kind of bent and twisted a little. Don't really know why it spun like it did a little, but it probably has something to do with the ductile strength and the of the gold. But so that's why I just thought it's cool, because minerals are cool, and sometimes geologists have to explain things to physicists. I've done that before in a Geo-Rant. But I just want to show you this. This is a piece of quartz. It's from Arkansas. This is not isometric. This is part of the most complex crystal system. There's hexagonal, which is divided into two separate subsystems, if you will. But without getting into the details of it, it forms 6 sides. And even though this is a very complex crystal structure, and like I said, crystals form because of the chemical bonds. Okay. The minerals, this is all SiO2, and the way SiO2 is arranged, you attach more SiO2 and eventually you get this. Okay. But this is also the most common mineral on Earth's surface. And it's one of the most complex structurally, and quartz is pretty hard too. I think it's a 7 in hardness. But quartz, unlike diamonds, has no cleavage. This will not cleave. Like you see these crystal faces here, it will not, if you hit this, it will not break off along planes. It fractures, it shatters. You hit it, it just busts. You can tell by the bottom here. And if you look at the bottom, you can kind of tell. Let me see if you can tell. See that break pattern? It looks a lot like glass, like when you break glass, because glass is SiO2. It's called conchoidal fracture. So quartz likes to break. Okay, but anyway, that's my rant for today, and I hope you learned something.